Hello everyone, welcome back to eKids Academy. Today I'm going to be teaching about the chapter Acids, Bases and Salts, Chapter 2 Chemistry, Class 10th CBSE. Now let's understand what are acids. Acids are those chemical substances which have a sour taste and change the color of blue litmus to red. Now let's see some examples of acids. Some common examples of acids include hydrochloric acid, that's known as HCl, sulfuric acid, and acetic acid. Acetic acid is found in vinegar. Now let's see what is the importance of acids in our daily life. So coming to our digestive system, the human stomach contains hydrochloric acid which helps in digestion of our food. So in our digestive system, HCl, that is hydrochloric acid, plays a very important role in digestion of food items. Coming to the food preservations, acid like citric acid and vinegar are used for preserving and pickling foods. So even in food preservations, acids like citric acid and vinegars are used. And coming to the cleaning agents, if you have observed in our households, generally mothers use vinegars, house mop cleaners, and mirror cleaners, etc., to clean these household items. So these household items generally contain acids which act as cleaning agents. Coming to the chemical industry, sulfuric acid is crucial in producing various chemicals including fertilizers and detergents. Now let's go to the next slide. So, what is the definition of bases? Bases are substances that can accept protons, H plus ions, when they dissolve in water. They often taste bitter and feel slippery or soapy to touch. If you have observed while you are bathing, if you touch the soap, generally it is slippery, soapy, it has a soapy feel, and when you taste the soap, it's bitter in taste. So soaps that we use for bathing are a basic example of bases, and some other common example of bases include sodium hydroxide, potassium hydroxide, and ammonia. Now let's see what is the importance of bases in our daily life. They are used as cleaning products. Bases like sodium hydroxide are used in manufacturing of soaps and detergents, which help in cleaning. When we come to the medicines, antacids, which are essential, are used to neutralize excess stomach acid and relieve heartburn. So antacids are medicines that are used to neutralize the excess acid that are produced in our stomach. So if you have observed the term acidity, generally people use eno, etc. So eno is an antacid which helps in neutralization of excess acid that is produced in our stomach. Coming to the field of agriculture, lime, a primary substance, is added to soil to reduce acidity and improve plant growth. So, if the soil is too acidic, some plants will not be able to grow properly in that. So, generally, farmers prefer lime uh, to neutralize that acidity levels in the soil. When we come to the chemical industry, bases are essential in producing various chemicals including paper, textiles, and certain drugs. Let's go to the next slide. What is the definition of salts? Salts are compounds which are formed when acids and bases react through a neutralization reaction. So, salts are the compounds that are formed when acids and bases react through a neutralization reaction. So there are some examples of salt. For example, common salt. Common salt is formed by the combination of hydrochloric acid and sodium hydroxide. It is the salt that we use in food. Seawater contains many salts dissolved in it. It's obtained on large scale from seawater by separating other salts from it. It may also be obtained from rock salt. First example of this salts are caustic soda. When electricity is passed through an aqueous solution of sodium chloride called brine, it decomposes to form sodium hydroxide. This process is called chlor-alkali process because of the products formed, thus chlor for chloride and alkali for sodium hydroxide. Next example is bleaching powder. It is produced by the action of chlorine on dry slaked lime. It is represented as CaOCl2. Through the actual composition is quite complex. On standing for a longer time, it undergoes auto-oxidation due to which bleaching action decreases. So now let's see what are the uses of bleaching powder. Bleaching powder, it is used for bleaching cotton and linen in textile industries, for bleaching wood pulp in paper industry, and for bleaching washed clothes in laundry. It is also used as disinfectant for water to make it free from germs. It is used as an oxidizing agent in many chemical industries. Third example of salts is baking soda. The soda used in the kitchen for making tasty crispy pakoras is baking soda. It is a mild non-corrosive base. It is the major constituent of baking powder. Sometimes it's added for fast cooking. Chemically, it is sodium hydrogen carbonate. It is produced by using sodium chloride as one of the raw material. Uses of baking soda are for making baking powder, which is a mixture of baking soda and a mild edible acid such as tartaric acid. When baking powder is heated or mixed in water, carbon dioxide produced during the reaction causes bread or cake to rise, making them soft and spongy. Sodium hydrogen carbonate is also an ingredient of antacids. Being alkaline, it neutralizes excess acid in the stomach and produce relief. Washing soda. Sodium carbonate is a white crystalline solid. Its solution in water is alkaline in nature. It turns red litmus blue. It has the property to remove dirt and grease from dirty clothes, and thus it is called washing soda. Sodium carbonate can be obtained by heating baking soda. The recrystallization of sodium carbonate gives washing soda. It is also a basic salt. We all know that during Ganesh Chaturthi, many idols are made up of what? Yes, many idols nowadays they are made up of clay, but in contrast of clay, there are many idols being made up of plaster of Paris. Plaster of Paris is also known as calcium sulfate hemihydrate. So this is when coming in the favor of the idols. When the idols are that are made up of plaster of Paris are immersed in water, they generally don't dissolve, and it takes many years for them to break in the water. So we should not use the idols which are made up of POP. Now let's come to the topic. Plaster of Paris, it is obtained by heating gypsum. At this temperature, gypsum loses water molecules and forms plaster of Paris. When gypsum is heated above 400 Kelvin, dead burnt plaster is obtained which does not have the property of hardening. Plaster of Paris is a white powder, and on mixing with water, it changes to gypsum, giving a hard solid mass. Now let's see what are the uses of plaster of Paris. It is used by doctors for joining fractured bones at right position, thus making for plaster to support fractured bones. It is also used for making decorative pieces, for making designs on ceilings. Now let's go to the next slide. Now let's see what are indicators. We are having four types of indicators that are natural indicators, synthetic indicators, and olfactory indicators. I am so sorry that I didn't add here the fourth one. Now let's see the first one, which is natural indicators. Natural indicators are the indicators that can be obtained from the nature. For example, red cabbage juice, turmeric juice, flowers of hydrangea plant. Now let's see what are synthetic indicators. Synthetic indicators are the indicators which are synthesized in the laboratory or industry are known as synthetic indicators. For example, methyl orange, methylene blue and methyl red are some of the synthetic indicators. Coming to the olfactory indicators, those substances whose odor changes in acidic or basic mediums are called olfactory indicators. For example, vanilla extract and onion. Coming to the fourth type of indicators is universal indicator. To judge how strong a given acid or a base is, a universal indicator is preferred over litmus paper. It is a mixture of several indicators. It shows different colors at different contract concentrations of hydrogen ion in a solution. Now let's see about strength of an acid or a base. Strength of an acid or a base depends on the number of H plus ions or OH minus ions produced by them respectively. Larger the number of H plus ions produced by an acid, stronger is the acid. Similarly, larger the number of OH minus ions produced by the base, stronger is the base. Now let's come to the next topic, that is the pH scale. Uh, it is a scale used for measuring hydrogen ion concentration. The P in pH stands for Potenz, which means power in German. It has values ranging from 0, that is very acidic, to 14, very alkaline. pH is a number which indicates the acidic or basic medium of a solution. Higher the hydronium ion concentration produced in the solutions, lower its pH value. pH means power of hydrogen ions. If pH is less than 7, then the solution is basic. If the pH is more than 7, the solution is acidic. If pH equal 7, then the solution is neutral. Pure water is neutral because of the absence of free ions. A paper impregnated with the universal indicator is used for measuring pH. Nowadays, pH meter, an electronic device, is used to measure the pH value. Now let's see what is the importance of pH in our life. Plants and animals are pH sensitive. Living organisms can survive only in a narrow range of pH range. Our body works normally within a pH range of 7.0 to 7.8. When a pH of rainwater goes below 5.6, it is called acid rain. When acid rain flows into the rivers, it lowers the pH of the rainwater and makes survival of us aquatic life difficult. pH in our digestive system. HCl is present in the stomach, which helps in the digestive system. During indigestion, the stomach produces too much acid, which causes pain and irritation. To correct the disturbed pH range, milk of magnesia, which is a mild base, is used as a medicine, which is also called antacid, as it reduces the effect of acid or acidity. Do you know that pH change leads to tooth decay? Yes, tooth enamel is made up of calcium phosphate and is the hardest substance in the body. If the pH inside the mouth decreases below 5.5, which is acidic, the decay of tooth enamel begins. The bacteria present in the mouth degrades the sugar and leftover food particles and produce acids that remain in the mouth after aging. The best way to prevent this is to clean the mouth after eating food. To prevent tooth decay, toothpaste, which are basic, are used, which neutralizes the excess acid. When insects like honeybee, ant, etc. bite, they inject an acid into the skin. That causes pain and irritation. If a mild base like baking soda is applied on the affected area, it gives relief. So, self-defense by animals and plants are done through chemical warfare. So if we take example of honeybee and ant, they inject an acid into our body when they bite us. So that acid gives us an irritation and a pain. So when we apply a mild base like baking soda on that area, it gives us some relief over it. pH in plants. Stinging hair of nettle leaves inject methonic acid in the skin, which causes burning pain. It is cured by rubbing the affected area with the leaves of dock plant, which often grows beside the nettle plant. So, if you know the nettle leaves, generally if we go or touch that leaves, it has stinging hair. So, if the stinging hair touches to our skin, it releases methonic acid, which causes burning pain. It is cured by rubbing the affected area with the leaves of dock plant. The interesting part is that the dock plant often grows beside the nettle plant. So if you are stung by a nettle plant, so search the surroundings of the nettle plant so that you would get the dock plant for that leaf. Salts, yes. Now let's go to the next slide. Now let's see what is the importance of salts in our daily life. Food. Table salt is a fundamental cooking and preservation seasoning. Health. Salts like Epsom salt are actually used in baths for muscle relaxation, and even Epsom salt is used for beauty secrets, etc. And coming to the chemical reaction, salts are essentially in various chemical are used in various chemical processes such as the production of fertilizers and the purification of water. And when it comes to agriculture, salts are used as fertilizers to provide essential nutrients to plants. Uh, Understanding of properties and roles of acids, bases, and salts is crucial in our daily life, from the food we eat to the products we use and the processes that drive industry and